Hello, welcome back to our CSCI 340 database. Here's our week 3 lecture. Okay, for today's we will talk about some database management system concept. So you see for this week is more like conceptual idea. So we're going to discuss certain problems, okay, encountered in a non-database information system, okay, environment. So maybe when you look at nowadays, you say, okay, it still doesn't make sense, okay. Even sometimes when people manage using, like, let's say the spreadsheet, like, let's say Excel, still kind of organized, but actually it's possible those are non-database information system environments, okay. So we will discuss what's the nature of data and try to define data-related terms such as entirety attributes. I think if you look at previous video, week 2, okay, so we know what's the entirety, what's the attributes, okay. So later we try to give you more like practical exercise, and then when you work on it, so help you to get more like idea way to get. And then also we try to define what's the storage related terms. Let's say like what's the field, okay, record and files, okay, all this name. So you see all these like terms, okay, names, okay. And also we try to identify 4 basic operations performed on the stored data. Okay, also compare some sequential access of data with the direct access of data. So here's a objective. And also we have some like basic principle of database concept. Also the how the data can be considered via like manageable like resources. Okay, and also some 3 problems squared by the data redundancy. So we'll talk about what's the data redundancy to remember. And also we will describe the nature of data redundancy among many files and try to explain what's the relationship between data integration and data redundancy in one file. Okay, so later here's are terms you need to be careful when we talk about data redundancy, integration. So all these the terms, and later if you see any questions asked about this, and you should able to answer. Okay, and we try to state the primary defining features of database management system. Okay, finally, when we learn everything of this evidence, then there's a reason why we need to use the database management system. Okay, so what are the features? Okay, and also why the ability to store multiple relationships is an important feature of the database approach. We know, of course, we talk about what's the reason, but we know we also using NoSQL, like try to like no non-structural database. Okay, of course, there's some reason like we still need to keep the multiple relationship, or sometimes like nowadays we don't care about the relationship. Of course, there's some reason like pros and cons. Okay, so also try to provide some support such like control issue, like data security, backup, recovery, like concurrence. So we know is there some like important feature of database approach. Also support data independency. So you know what's data independency. Okay, and also it's an important feature of database approach. Okay, so all these start with a data processing system. So you know, because data, okay, data was like stored in different format, in different files. So here's a different format and different file, you say. And they're not often like share among different programs that need it. Okay, so kind of like nationalisting the like duplication of data in redundant files. Okay, maybe we maybe have one file for system A, system B, and using same, but they were like exactly the same copy. Okay, so it's a redundancy. Okay, and that's why it kind of like lead towards the understood about the file design. So it causes a result like it's the redundant of the data. So within the individual files, then we start thinking, how can we reduce the redundancy, right? So there's a follow-up question we ask. So also the files, so they often like cannot be rebuilt after being damaged by software error or some like hardware failure. Okay, all this and data that was not like secure, and also the unknowable like to thief, like malicious like mischief, like by the people inside or outside of the company. So all this when we talk about the data, okay, also those like processing system. So any systems, okay, we process it, so it's possible, and then we save it in um like different files. Okay, so we have maybe exactly same copy of data using by two different systems. And also some programs, okay, so where like usually written in such a like a manner. So if the data was like stored change, then the program had to be like modified to continue use the working. Okay, if something like this, okay, if the data change, then we need to modify, okay. Or the change in everything from access method, maybe let's say to the text table, so they require the programming change. So it's like possible. So it's one of the data, okay, anyway. So right here, before we are using like database management and record and files, maybe we just like put everything right here inside this like the things or objects like in our environment. So we just like keep track on it. So salesperson name, city, state, office, like commission per year of hire. So all these like putting together. Okay, so here you will need to ask the first one is what is the entirety set? Okay, so the collection entirety of the same type. Okay, so maybe like of the company's employees. So right here maybe the employees. Okay, and sometimes we're adding like some office location somehow. Okay, so are we putting together? Then we need to identify all these entirety set. And also we have the attributes, okay, right here. So all these the attribute will be the property, okay, characteristics or the fact that we know about an entity. Um, if you still remember the EL diagram, we talk about the entity, that means the object itself, and then we do have the attributes. So we talk about attributes, that means the columns, okay, the ID, number, the name, cities, okay, sometimes like we put in the address, okay, or the office number, what's their commission, year of high, okay, all these will be their attributes, okay. So some of the attributes have a unique value within an entity set, okay, so between this. And of course, we'll pick some unique, say like as a primary key, okay. So it's a key field or like we have so many names. So we have records when we say row. So all these like will be a structure like this. So each record. Okay. So if you hear what I say, okay, which record, that means the row. Okay. And also we have the field. So we have the column attributes field, all this representing right here, the column right here. And then the file, entire structure will be the file. Okay. So you see multiple names, try to not to be confused. Okay, so we talk about whole files. Okay, so the table, the file, and then record each row. Okay, the field, columns, attribute. So they representing the same things. Okay, and then the record type. Okay, if you remember the record type, so it's a structural description of each and every record in the file. So okay, record type, and then the record like occurrence or the instant. So it's like a specific record of the salesperson file. So it's kind of like this. Just talk about it. Okay, and then after we talk about kind of like some terms, okay, what between the records, files, okay, then we'll talk about like how can we retrieving and manipulating the data. So four fundamental operations, okay, can be performed on stored data. One is like retrieve, okay, or read, okay. So later when we learning SQL, those query including like read, that means select. I think most of you like work in the lab or prepare for assignment, so you know like select, right? So we try to read it, okay, looking for record contents without change it, insert. Okay, so if you look at the data import, we try to, after we use the database, we try to create and then insert the data. Okay, so first we need to create the table, and then later we can insert adding a new record to a file. Okay, and then delete it. Okay, so we can delete it. So delete a record from file update. We need to change it. Okay, we have not yet covered all this, but later when I give you some sample, some question, then you will try to practice like how can you insert, delete, and update the records. Okay, and we do have called the sequential access. That means that we try to retrieve all and or a portion of records of files. Okay, one after another. So in some sequence. Okay, and start from the beginning until all of the required record they have been like retrieved. One is called a physical sequential access. That means they are retrieved like one after others. They are just stored on the disk device. So kind of like this by this. And then one physical, of course, there's one is logical. Okay, so we have two sequential access, physical and logical. So it kind of like a records like retrieve in an order based on the values of one of the combination of fields. Later, if we the good example right here, maybe if we look at physical sequential, that means we insert all the records, right? So when we select select all of them, then should be like physical sequential access. But later when we giving certain connection or like combination of the field putting together, then maybe it will become a logical sequential access. Okay, so in an order based on the values or one or combination of the fields. So here's the difference between them. Okay, and we also have a direct access. That means we try to retrieve the single record of a file, sometimes like subset. Later you know what's the subset. We try to like create some record subset. Okay, based on one or more values of a field or combination of field in the file. Okay. So here's the kind of like the crucial concept in the information system. Okay. Also, it requires some hardware storage device with accumulated direct access. And also it requires software so that we take advantage of the hardware capability and store and retrieve data. So in such way for direct access. Okay, so it's got the data retrieval method, one of the direct access. And then we can move on one is database concept. So including the first one, data, so they are manageable resources, and then with the data integration, data redundancy, okay, and then was a multiple relationship, data control issue, and data independency. So we have like 5 points going to talk about it. And have data as a manageable resources. Okay, so the creation of the data like central environment in which like a company's data so can like truly be like thought of like significant corporate resources. A key feature of this environment, so the ability to share the data so among those like inside or outside the company. So who like require access to it. So just say there's a definition of like database. So inside, outside. So if they want to access it, require access, they can get it. And for integrity and then redundancy. So the ability, so achieve the integrity, that means well, at the same time storing data, there are no redundant, okay, fraction, okay. So also like along this, so essential define the feature of database approach. Later you see more what's the integ integration of like the redundancy, okay, and later we will the integrity and then redundancy, okay, and right here we talk about integration. So lots of different terms, but right now just remember the like some terms name, okay. So later in practical, then you can tell what's the of course sometimes we can avoid, okay, um um, the redundancy, or how can we make sure in I also say that integrity because the make sure like okay they're consistent. Okay, so later I say okay, so if we change it, another one should be changed the same. Okay, also we have some like the multiple relationships, so the ability to store data representing entities involved in multiple relationship, so without introducing the data redundancy or other structural problem. So it's called a multiple relationship. So this idea and kind of like concept like come on. So what's the control issue? So establishment of the environment. So they can manage like certain data control issue, let's say the data security, backup, recovery, okay, concurrency control, all this is a control issue, whereas we say independency. So it's talk about like a premise of high degree of data independency. So, but minor just like it's just a definition, and then you later you see more example. And as a manageable resources in the information system environment involve like different type, like let's say the hardware itself, network, okay, hardware maybe a storage, the network, what kind of cable they put in, the application software, system software, okay, and also what are those like people, and most important, data, okay. And we talk about some like historically the data that not been like the highest priority concern, not example, but actually it changed stuff. We storing data. We talk about big data after we using data to training AI, like giving different type of models. All this as an operational, like technical or like strategical operation, so become more like dependent on the information system. So we are really rely on it. So that's why it increasingly become recognized as an important corporate resources. This idea. And the corporate community so become more increasingly like convinced that okay, a firms of data can provide significant competitive advantage. Okay, so you see there's a position title like the analyst. Okay, so we try to retrieve the data. Okay, so it be, became like clear that like data we have to manage in an organized way. So here's the idea why we need it. So make sure okay, data as a manageable resources, including for data we can generate okay some like equipment, inventory, people, money, all this can be data. And we need to have some like software, okay, utility that can like manage and protect the data. And also like can be like critical like cooperate resources. Okay, all this like when we need to access it. Okay. And also we like integration and then try to like reduce the data redundancy, all this. So all this we create a database managed system. So here's the idea. So finally we introduced was a database managed system. So first one, like we talk about the re-engineering. So data is like aggressively using to redesign business process. Okay, so this is one. And then we also the e-commerce. Okay, the database. So at the heart of every website. So maybe the company, customer, conduct business, like purchase orders, like this. Okay, checking. Also, we have the ERP system, the enterprise relationship. Okay, like this. So it's like collective collection of like application programs so built around the central database, all this. So it's the ERP, okay, system. Okay. And this one is not the ER, but not the en entity relationship, but this one is the enterprise relationship. Okay. And also we have the integration right here, so ability to like together the pieces of related data within an information system because I think here's the one point we talk about that like because um we have different system, different application, and then we have like different copy of the same data. So how can we like have a better integration of them and also try to reduce the redundancy, same fact. So the business environment store more and um, than once of the within an information system. So how can we reduce the redundancy? So that's how always they come together, integration and then the redundancy. Okay. And of course, redundant data, we try to take up a great deal of like extra disk space and storage there is like cost money. Okay, it's a cost. Okay, so if the redundant data has to be updated, so they maybe take additional time to do that. They also cause some like major performance issue. Okay, so why do we need to updating the redundant data like so many times? Can we just update once? It's possible, right? So this idea. So that's why we need to have a database managed system. Also, there's some like potential of the integrity. So I talk about the integrity right here because when you have redundant data. Maybe we only update the first one, but you forgot to update the second one. So it causes conflict. So you never know like which one is the latest one. Okay. So or which one is accurate. So it causes integrity. Okay. So we make sure they are exactly same. So this one is the accuracy of data. So I say like inaccurate data. So leave the whole information system a limited value. So that's why you see the integration of redundancy and then one's the integrity. So it's right here. And also when like all the copies of redundant data, so they're not updated consistently, then it cause the problem. Okay, so always just one. So here's the issue. And if right here, if we have the redundant data, you see maybe sales file, accounts, right? Credit files. We have all the like customer number, customer name, also customer address. So we need to keep all these like exactly same copy in these three files? No way. How about we just like have another table, okay, and the copy just save all this like customer information and then just put customer number. That's it. So we don't have to let the customer name and customer address like repeating, like showing up. Okay, right. So it's called the redundant data right here. So it's the customer name and customer address. And also the data integrity problem. Okay, so if we have because we right here, if we change certain information, let's say one record, we change the address. So right now we don't know which address is the correct one because the redundancy it caused it. Okay, so in this moment I cannot determine is this address is the latest one or this address is the latest one or which one is the correct. So it causes an issue of integrity. Okay, accurate. And of course, like we have more right here. So we have like two files. So one is salesperson or a commission right here, and then we have the customer files. Okay, we can put in and then salesperson. So also for our design of tables, our database, if you remember, we have the we talk about the when we draw the DR diagram. So we also talk about that. But later when we really talk about how to really design the tables, then you will knows better. So he just like showing the general hardware company files will be like this. Okay, so customer and which salesperson following in this, and then maybe the city headquarter. Okay, and also right here combining. Okay, so you see the customer name. Okay, right here. So more records. Okay. And normalize one thing, here's the terms you need to know. So it's like occur in the poorly structured files. So it's the problem like array. So when we have two different kind of data, like the salesperson, customer data, so they're merged into one file. That's a really poor design. Okay, anonymous because I don't know what this file belongs to. Like, I think it belongs to the customer or salesperson. Okay, so right here. So here's the idea. So we need to like deletion of anomaly. So if you delete the customer, there is record only one for the salesperson. Maybe you also delete the salesperson. So it's a deletion instruction. So let's say if the like the general hardware couldn't add the data about new salesperson because you don't have assign a new customer, so you cannot insert it. Okay. Also update. Okay. So it may be some redundant data in the database files. Okay. So then must be updated like each place exists when it change. So and normalize it causes like three problem: one deletion, insertion, and update. Just be aware of it. So database management. So it's a software you need to help us by storing, retrieving the data. So give the end user the impression like that the user will integrate, even though data can be stored and no redundancy at all. I would just like put it right here, no redundancy, not really accurate because we still have some redundancy, but not as this like above type redundancy. Okay, that means that for certain attributes, okay, still need to be like appear on other tables, right? And we can show you right here. So multiple relationship right here, they call a horizontal solution. And showing like the salesperson, sales name, commission percentage, and then giving what the customer name. Okay, and giving it. Okay, so you see the horizontal solution is that I put all the customer number like in one row. Okay, and then I put all the customer name and then HQ city right here. Okay, and customer number. So you can show it's a horizontal solution. So when we have horizontal solution, of course, there's a vertical, but I would say in more practical, we always do it in a vertical solution because sometimes it's not a good design like for like putting all the customer number in one like is it should be one column or multiple column, then how can we define? So it's a poor design. So that's why vertical solution will be better. Okay, so maybe we have the like sales table, okay, and then put it in vertical, and we have the sales ID, and then we have the salesperson ID and the customer ID. Okay, and then it will be okay. then it will be way better than using the horizontal solution. So right here. So here's the design. So just need to know we have horizontal and vertical. Okay, but in more practical, we're using the vertical solution. Okay, for multiple variations. And okay, kind of like going right here will be the data control issue right here, including the data security backup, recovery, and then concurrence control. Okay, right here. For the security, OSA is a really broad topic. Okay, if later if you learn cybersecurity, we do talk about database a little bit. Okay, but here we need to think about just like knowing, have some concept. Okay, what's the protecting the physical hardware, also defend against the hacker attack, and so how can we encrypt the data, transmit over networks, and educating the employees like on some importance of protecting the company data. Okay, so actually a lot. Okay, encryption is important, and also like try to avoid the attacker or like putting the USB copying data is like some USB containing the malicious software. Okay, or they being like injected with certain application. So we need to be careful, and also for database we need to think about the backup and recovery. Okay, data can be lost or corrupt in any variety of ways. Okay, maybe certain disaster like fire, hurricanes, earthquake, tornado. Okay, tsunami. You never know. Or the hacker attacks. Okay, or computer virus. Or this, or the poor written application program as read and write and then cause corruption case, but or unintentional error. So you never know. And when we're learning computer, okay, so here is one thing we always try to overlay when you learn operating system. So one thing you need to know, we always like try to predicting, okay, next stage, try to avoid the problem occur. But we need to be prepared. Okay, most time it's like, okay, so actually in a company, we really prepare for like backup and recovery. What's the backup strategy? Okay, system design. So later, if you're taking this course, then hopefully you'll learn about design recovery is important. And also we have some like concurrency problem. Okay, when you update to a database, can like interfere with each others. So maybe resulting the data values will be incorrect. So it's possible, right? So when we have database managed system, so must be like designed to protect the database from such eventuality. Okay, so how can we protect? Okay, if we going to read this column, this row, okay, or when we maybe in an application update, so which one go first? Which one go second? Okay, so we need to prevent the concurrency problem. Okay, and also the data independence view here the term. So um what's the data dependency? So if only for any reason for the storage characteristic of the data, so they have to be changed, then the application program itself also have to be modified. So often like extensively, so it's called a data dependency. So once you change, we need to modify the application. But for the data independency, that means that we have to store the data, okay, and then some like programming environments or many type of change. No matter how we change the data structure, or possibly like not required to change the application program. So here's the what we learned. Okay, if some of you taking web programming, or like if you're working some application, okay, no matter how I change the user interface, like you using React, later when we just need to change the maybe the API server or the database SQL, then we can still return the same like format of the JSON file. Okay, that means like for the front end, I don't really care how the data format how it looks like. So just like based on the standard how we define in the API server, then I will get what I need. Okay, so I don't have to change it. Okay. And if it's the dependence, that means that, okay, if the data change, then I need to modify, okay, the application. So here's the differences between dependency and independency of data. Okay. And also the DBMS, database managed system, we have different approach. A major one is a hierarchical, okay, if for like navigational network, okay, or like relational, okay, later. When also we have the object oriented, so it's kind of useful for variety of like the niche application. So we have different approach. Just need to know we will talk about the relational database management system. So more like commercial, it start from 1980. So just need to know. And quickly cover like hierarchical and network. So we call it a navigational approach because it's like program to navigate through the hierarchical networks of data fund, try to find the need data. Okay. And it's like developed in 1960 and 1970. I was okay with that time, but we more so it kind of like suitable only for like mainframe computer. Okay, and at that time, kind of like elegant solution to the redundancy integration problem at that time. Okay, but it's kind of like complex and difficult to work. Okay, so now it's considered as a legacy system. Okay, and here's move on to what we always like talk about is like called a relational database. Okay, kind of like became commercial around like 1980. Okay, so it's like more like preferred DBMS approach. So it's remained like so even right now. So we talk about that. And also we do have the object oriented. Okay, so if you learn Java, you learn this term object oriented. So it's more like useful. Okay, for the variety of the niche application. So it's interesting to note that some of the like key of the object-oriented database concept so also found on their way. So some of the main stream of the relational database and some describes the taking hybrid object relational approach to database too. Okay, so here's the another type. Of course, just to address the last part is the NoSQL because it's a trend, okay. It's useful using the relational when we introduce a relational database or object-oriented database, okay. But of course, right now we have NoSQL, okay. So also we have similar design, but we don't really care because we have a bunch of data, okay. So we want to increase the speed of like retrieving, okay, instead of like building the relation. But I would recommend we need to learn both. And so far we already go through all the conceptual of the database management system. So start from the like reason why, okay, and then for the integration, and then for the data redundancy, okay, and of course how can we provide the data integrity, okay, if you remember the terms. Yeah, and then some key concepts like to try to avoid the anomalies. Okay, so what are they included three of them? Okay, so sometimes you need to remember that those like terms and keyword will be okay. So that's it for this lecture. Thank you.